Section 5.2 in our geometry book here talks about ways to prove that quadrilaterals are parallelograms. Now, a lot of these theorems are going to be converses of theorems from section 5.1, which were characteristics of parallelograms. So we're going to find out is if we have those characteristics, we then know that we have a parallelogram. For example, theorem 5.4 says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if we have a quadrilateral here, and we say these two sides are congruent, and these two sides are congruent, then we know that this is a parallelogram. So if it's A, B, C, D, then we say our conclusion is quadrilateral A, B, C, D is a parallelogram. And if this were a proof, or if we were trying to prove this in a proof, it would be, the reason would be opposite sides congruent. Okay. Our next way to prove that a quadrilateral is a parallelogram is if one pair of opposite sides of a quadrilateral are both congruent and parallel, then it's a parallelogram. So if we have one pair of sides, so that'll be like one pair of sides, both congruent and parallel, then this must be a parallelogram. So if we have these labeled here, we would say our conclusion is quadrilateral FROG is a parallelogram. And our reason, if this were a proof, would be that one pair of sides is both congruent and parallel. Next is theorem 5.6, which says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Sorry, I think I just said sides there. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if we have these two angles congruent, and these two angles are congruent, it's not just one pair of opposite sides, it's both pairs of opposite angles are congruent. Our conclusion is we have a parallelogram. And the reason, both pair of opposite angles congruent. Theorem 5.7 says if the diagonals of a quadrilateral bisect each other, then we have a parallelogram. So I'm just going to draw in some diagonals for this quadrilateral here. And when we say they bisect each other, that means this one is split in half by this one, and this one is split in half by this one. So we have two equal parts here. And our conclusion is that we have a parallelogram. And the reason, diagonals bisect each other. Okay, and it's easy to get confused with this. Sometimes you'll have a quadrilateral, and you'll have like these two congruent, and these two congruent. This is not diagonals bisecting each other right here. This is no good, because this one's not cut in half, and neither is this one, so this is not a parallelogram. Okay, so to sum up, our ways to prove that a quadrilateral is a parallelogram, you could show that both pairs of opposite sides are parallel, first of all, which is not one of our theorems because that's just definition of a parallelogram. This one gets overlooked a lot. If you can just show that opposite sides are parallel, you're done. Second was the first theorem. Show both pairs of opposite sides congruent. Show opposite angles. Oops, that's a typo. So we show opposite sides congruent, opposite angles congruent. Oh, sorry, that's not a typo. Must have my head screwed on backwards. This is the one pair of opposite sides. One pair of opposite sides, both parallel and congruent. And then both pairs of opposite angles congruent, and then the diagonals bisect each other. Just very important that both pairs of diagonals bisect each other. So these are the ways to prove that it's a parallelogram.